Alright, so we're back on the surface grinder chuck mounting, and for those of you that may have missed the first video, this chuck is slightly oversized for this machine. So what we did was we took a little off of the shoulders here to make sure that we can cover the full surface of the magnet when we resurface. And as a reminder, I lubricated the interface between the bottom of the chuck and the machine. Both surfaces just have a very, very thin layer of frog lube, actually, which I'm really liking for a corrosion preventative. It seems to be very, very good. Anyway, the machine has enough travel to do the length, but not quite enough travel to do the width. So where we left off in the last video was I ordered some stuff from Suburban, who's the manufacturer of this particular chuck. This is one of their Magnum Force chucks. I guess it's a very high holding power, and it's unique in that it's a combination fine pole spacing and regular pole spacing. Okay. So anyway, the parts came in, and honestly, everything's fine. You know, I bought them. I ordered the hold downs from Suburban, and these are the ones that are supposed to go with this chuck. And you know, in general, they're okay, right? But they don't really work on this particular machine. This machine doesn't have T-slots. It has a single tapped hole, and you know, the spacing just doesn't quite work out, and I was going to have to modify these, so it's kind of in a quandary there for a little bit. So I decided to set these aside and save them for another machine or something like that. So I made my own. And you know, sorry guys, but I made it off camera. I just wanted to get them done, and this is what I did. I just whipped some up, okay, 2 of those, okay, that have just the right spacing that I need, and all that. So let's shuffle down here a little bit. And they have a little step here too that catches the edge and positions the edge real nicely. Okay. Now, you know, surface grinder chucks, you don't need to reef them down super hard. You know, this is a 1/4 screw. It's, you know, roughly 6 millimeters, and that's about all you need. You're not it's not like a milling machine where you're plowing material super hard. Now the thing that I do like, this is the back rail for this particular chuck that I also bought from Suburban. Thanks, Don, if you're watching. And it's made out of cast iron, which is great. Cast iron's really nice on the surface grinder. It has this unique quality that when you turn the magnet off, it lets go, and you know, it doesn't hold residual magnetism, and so it releases really well. So if you make fixtures that go on the chuck, and you really want them to just kind of, you know, pop loose and literally lift them off like so, cast iron is a good choice, although it's not particularly hard. So if you want durability, it might not be the best choice. And you can see that we have this fence, the actual surface that we use here, and then this is the mounting surface, okay? And you can see that that's raised as well. And what that does is any dust and grinding grit and whatnot can kind of go under there and then find its way out down into the bottom of the machine. So that's kind of the design intent there of the okay, so it's on now. There's always this question about how high to set this thing, right? And I like to set them pretty low, and I just use a couple of pennies and I stick them under the chuck here like so, or excuse me, not under the chuck, under the you know, why does that always happen when I'm filming? Drop Allen wrench. Okay, and you know, it sets it parallel, and it's close to the bottom, but not too close, and you know the game, right? Yeah, see there. Oop, almost dropped it again. All right, snug that up. All right, can do it by feel there. Okay, and then I'll torque those down a little bit. Then I just pop those out. Just pop those out. Say that again, and it'll come out. Oh, blasted. There it goes. Okay. Must have a little burr under there or something. So anyway, that's the correct spacing, and I can drop down and kiss that off. We're going to side wheel that, and I'll show you guys how to do that. A few people have shown that, but we'll show it again, and maybe in more detail. Okay, so let me tighten that up, and then actually I already screwed up. The first step is we need to dust this surface off and rough it in, and then do a finishing pass on it. And then once we're happy with the flatness of this, then we mount this and take care of that. So let me back up. We want to make sure before we start grinding the chuck surface. Put it a little closer, that this outer edge is parallel with the travel. Sometimes you use a square on the front to kind of, roughly square something up on the machine. So it's nice to have that surface parallel with the travel. Okay, so it's pretty good. It's got a little wow in it. I mean, if I was being real squirrely about this, I'd probably grind that edge, but it's kind of a pain in the neck to grind that edge. So the ends are the same, but there's a little low spot in the center, so it's got a little hook in the middle. It's only what is that? One and a half. It's about 1.5 thou, so it's not too much to worry about. And you might use a machinist square or something like that to put a block on there to kind of square it up. But if you're doing precision work, you'd indicate that. So it's not that big of a deal. You just want to be kind of workmanlike there. Check that. All right, so let's see what's next. I think we'll change the wheel. All right, so we're going to change the wheel here. And we're going to put I prefer for grinding the chuck, since the chuck is not real hard steel, and it's a composite material where you have steel and stainless or steel and brass. I prefer a harder wheel, and I seem to get better results when I use a slightly harder wheel. So we're going to take this one off. And this one's a left-handed thread here. Mine has a stud, and then we use a little McPuller here to pop it off, and it should just come right off. Yep. Okay. Now this particular hub here, this is a balancing hub here, where you set this up on some leveled ways and an arbor, and then you can adjust it for balance. And this is this particular wheel here. This is for nice finishes here, and it's a 60 H hardness here, so aluminum oxide. All right, so let's set that aside, and we're going to put this guy on here, and this is a Norton 32A. 46 grit and K hardness. Okay, and I have enough hubs that I just leave them mounted to the hub so that I don't have to true the periphery. I just have to dress them and to get a good cutting edge going there. Okay. All right. And then, some people, they wonder how tight to make this here, and I'm just enough to hold it with my hand and then tightening snugly, okay? So it's not once again, not a a reefing situation there, okay? All right. So we'll dress the wheel, and then we'll do some roughing and finishing on the chuck surface, and then we'll do a 5-block test just to make sure we're nice and flat. So here's a little trick. I have some these are temperature indicating tapes here, and I have one here close to the grinding wheel, and then there's another one in the back on the motor. And so, you know, when I start, I just kind of note the temperature of the indicating label, right? And then I let the spindle run for a little while and kind of come up a little bit. So what I'm looking for is some kind of temperature rise. So I just touched the tape, so around 72 degrees Fahrenheit or 22 Celsius, something like that right now. And we'll turn the spindle on and we'll let it run for a while, and then we'll come back and we're looking for some rise in stabilization. So to get best results, your machine needs to be, kind of at operating temperature, and the ways have oil in them and all that. So let's fire it up and we'll come back in a little while. Okay, you can see the temperature's come up nicely and it's kind of stabilized. That's as high as it came up to, and I've been doing some rough grinding just to get most of the meat off of the chuck. We're going to look at that just right now. Okay, so I've done some rough grinding on the chuck, and just to remove most of the material to level it out, or to make it parallel with the machine, I should say. I'm going to let it cool off a little bit. It's not warm even. It's just slightly above ambient. So I'm just going to let it cool a little bit, and I'm going to redress the wheel. We're going to use a single point diamond in this case. Magnets on too, for those wondering. We use a single point diamond, and we're going to do an open dress for this particular type of operation, okay? We're not after super fine surface finishes, so we want cool cutting is what we want. And there's the different types of possible ways to dress the wheel. This is the coolest cutting, what we call an open dress. So, well, I might as well go ahead and dress it while I got the camera running. Okay, I want to be on center line, eyeball center line. I'm going to come down. I'm going to come down until I feel some grit in my hand here, just a little bit. I'm basically in the center of the wheel. Oop, this machine moves so easy. Okay, I got a little bit there. Okay, and notice the rate that I'm running at. I just down fed a half thou. Okay, I'm going across there pretty quick. Okay, another half thou. Okay, another half thou. Another half thou. So what I want is that kind of a coarse open dress, another half thou. It's looking pretty good. One more. And you can see I'm advancing pretty quick. I'm looking at the wheel, and I think I want one more on there, just for fun. Okay. Alright, so I'm going to call that okay. Then we'll come down, pick up the surface again. We're going to do a semi-finish, and then we'll do a finish. Okay, so I got a really light pickup. I put some Sharpie on here just so I can see what's going on a little bit better, since we're really not taking much off. Let me make sure, yeah, okay, it's going to clear the tripod. Alright, let's go ahead and give it a little. Okay, so it's catching on the end there a little bit. see. No, I don't know if he, yeah, it's kind of hard to see, but it's just catching a little bit on this, this far end here. Let me go across that and we'll come back in a minute. Okay, so you can see it scraped a little Sharpie off right here. So I'm going to come down just a little more, a few tenths, and then come back across, and we'll see what we get when we do that. Okay, so after getting the ends down, you know, it was kind of curled up at the ends a little bit. And so now it appears it's cutting most of the way across now. So what I've done is I've put a little WD-40 down to help cool it. So in this case we're going to be doing quite a large step over and high speed, basically, is the kicker here. Still going to need a little more, but we're getting close here. Pays to take your time on this, do it right, and then, you know, you're not wondering if it's out or not. So I'm basically going as fast as I can here, because I don't want to make heat. Okay, so it's starting to extend in to the middle here, so we're getting real close here. Let me wipe this off and we'll do another one. Okay, so we're real close now. What I want you to look at is, I want you to look at the spark trail. What we're looking at is that it's even all the way across, and it's very, very, very small, okay? So that means we're just barely grazing it, all right? So the sparks are even from end to end, and there's just barely any of them there. That means we're just scuffing the thing. And yep, there might be a little, yeah, there might be a little hole right there. It's a slight low spot. If you watch, the sparks kind of disappear for a second, then they come back. Yeah, so we're going to need another pass. But I'm doing a big step over here, full turn of the cross feed. All right. Put some more juice on there. And we're just going to down feed a whisker, a couple of tenths, if that. Yeah, there's a little low spot right here on this side. And it's evening up there. So we got a little low spot on my side here. Oops, closest to me. The rest of it's looking good there. Alright, well, this is what you do. La-di-da. Okay, so you know, when we were just a minute ago, we were talking about that there was a low spot on my side and in the middle, but I think I got the camera adjusted so that you can see it. So here's the outline of it here. Let me trace it with a Sharpie so you guys can kind of see it here. So it's really kind of amazing what you can see, right? And I don't know how much that is, but it ain't much. But there's a difference in, well, it's hard to see. there you can kind of see it a little bit. Anyway, that's the area we're going after now, and it's real close. All right, peace and quiet now. So we're looking pretty good. I'm pretty happy with the results. I got that low spot out of there, and didn't have to redress. It ran fine. So we're gonna clean it real good here. And so now we're kind of, before we put the rear fence on, we really want to kind of test it. And you know, what we care about is how it grinds, right? I mean, you can run an indicator around there and it'll give you some idea where you are. But what we're going to do instead is we're going to do a thing called a 5-block test, right? I'm going to turn the magnet off here because otherwise it's going to be real annoying. So we've got some blocks here, some small steel blocks, and these are just soft steel. We're going to position 5 blocks on here, like so, on the magnet, not on the part that ain't magnet. Okay, something like this. Okay, that's why they call it the 5-block test. And then we're going to grind these parallel, okay, and then we're going to measure them really, really carefully, okay, as close as we can, basically, and we'll see what, and that exposes any weaknesses in the grinder and the chuck condition too. So initially what we'll do is we'll go ahead and just you know, grind one side to dust it off, so to establish a plane, and then we'll position them in the extreme corners, and this is basically testing the whole surface. Now, why this is good is because, you know, if you did a whole plate that size, your wheel would break down, and you couldn't diagnose whether or not it was your wheel degradation or what. So here we're just grinding a small surface, so the wheel is kind of preserved, and you know, it's really the true condition, you know, parallelism condition. So I'll go ahead and grind the first side off camera, and then we'll come back and grind the opposite side, and then we'll take some fussy measurements. Pretty cool. Okay, I got 5 blocks on there. I've ground, actually I've ground both sides, and just so that they're parallel and, you know, basically all the same size right now. So what we're going to do is we're going to come down a couple of tenths, and we're going to skim all 5 of them in this position. So we got 1, 2, 3, 4, 5, and I've got them numbered so we know where they came from off of the chuck. So we're going to skin these, and then we're going to take a very careful measurement, and we'll get a look at them. So I'm just going to come down about 2 tenths here and go for it. Should get a, yep, should get a little spark. So we're using the full travel of the machine here. And this is always the, you know, grinding the chuck is always the hardest thing to do, because, you know, well, there's a lot of area for one, and you're just running it all the way to the extremes of the travel, right? You know, and there's wheel degradation and that kind of stuff, so, going on, when you're doing the chuck anyway, so. This is why you do 5 blocks, is they're isolated, so they don't influence each other like a large plate would, right? I should probably mention that these blocks are just soft steel. They're not hardened, which for this particular test doesn't make any difference, as long as we can get a reasonable measurement on them. Yeah, I think we have it. All right. So, actually, you know what? I'm going to go back across them and spark out on them, and then we'll measure them. Be right back. Okay, guys, we're going to check this, guys and gals. We're going to check these, the little blocks, okay? So I'm going to zero up on number 1. Let's talk about this gauge here. This is a Johansson gauge here. And each little tiny division is 10 millionths of an inch. So the 1 that you see there, that 1, that's 1/10,000th of an inch, okay? So that's a 10,000ths divided into 10 parts, which is 10 millionths, okay? So this gauge is like so fussy, it's maddening. So we're going to zero up on the first one. Now, you know, the other thing that matters at this point is you can't touch these things very long. So hopefully you can see, this should be pretty easy to see on the video. Now you can just see that just barely touching this thing and turning the knob, oop, I'm doing it with my left hand too, so forgive me. Yep. This thing will, okay, there we go. Oop. Well, this thing will drive you to tears, honestly. Okay, so we're zeroed up on the first one. So what I'm going to do is I'm just going to slide it out of the stylus real quick, get my hands off of it. Okay, we come back to 0. So if I hold my hands on this very long, the thing will start to grow, and the needle will just go bloop, and it'll just go up. Okay. So let's go through the blocks. That's number 1. I'll try not to bump the camera here. I'm straddling it. So let me get this one out of here. That's number 1. This is number 2. Okay, so it's off a little bit. So I get 2 lines there. So that's 20 millionths. Okay. Okay, number 3. All right, that one's off quite a bit more there. What is that? 80 millionths. Okay, so still less than a tenth. That's 80 millionths. That's number 3. That's the middle one. That one's minus 10. And number 5. Plus 10. Okay, so let's see. Let's go back through that there. Now let's put number 1 back in. Make sure. Oop, where'd he go? Or where'd she go? Let's put number 1 back in there. Okay, and we're still good on the 0. All right. So number 3, which was the middle 5 of the 5, is tall by 80 millionths. Okay, so what that means is there's a hole in the chuck, and we're talking like a small hole of about 80 millionths compared to the rest of the block. So now you guys might go, wow, that's really close, blah, blah, blah. Well, guess what? We're going to go fuss with it some more and see if we can do better than this. Okay, you know, ideally I'd like to be within 20 millionths on all these blocks. That would be really nice if I can get to that. So let's look at number 3 again real quick. There he is. Let's get out of there. Make sure it's sitting on the anvil. Everything matters at this level here. Yeah. Make sure it settles. Yeah, so 80 millionths is what I see on that. Okay, all right, so we're going to go take a look at the chuck and probably do a little more dressing on the chuck and drive ourselves batty. So I know guys are out there screaming, well, keep your hand on it. Let's just watch that. So what I'll do is I'll just put my fingers on this and we're going to watch the needle go up. Okay, yeah, it's going up. Some of my heat's probably going into the anvil there too. Actually, I'm going to take it out and I'm just going to hold it in my fingers here. That anvil's cool too, so. Yeah, there you go. So, oh, well, actually, we'll do that. We'll let it cool off. So it grew 20 millionths there. Okay. And it's starting to come down slowly. It's kind of neat, all materials expand when they warm up, except antimony, I think. But yeah, there it's dropping. Pretty neat to be able to see that, though. That's kind of cool.